And for some examples of subtracting real numbers, we're here at the bottom of page 1 in the notes for section 1.6. And again, page 62 of the book has a helpful reminder of what we're talking about here. To subtract, we can just add the opposite. The additive inverse is what you'll hear it officially referred to. I always want to be aware of the official vocabulary so that you understand when directions come along the way. I try to talk in a way that uses both kind of some everyday words to help you connect, as well as the official stuff that you're going to see in the book, and how you're going to be able to interpret it on exams. Okay, so let's do some examples here. We've got number 10, 5 minus a negative 17. So because we're starting at subtraction, you're going to change the subtraction to adding the opposite, which means that you change the subtraction to add, and then we're going to make this the opposite. So instead of a negative 17, it's going to be a positive 17. Okay. So then we'll bring down the 5 and the 17. A lot of you will be able to do this in your head, especially if you were confident in adding and subtracting positive and negative numbers the last time you did this. Okay? If this is rusty or brand new, or it never really clicked the first time around, I would suggest you try this method, because it'll really train you and get you ready for the algebra. Okay. So now we're just adding two positive numbers. 5 plus 17 is going to be 22. Signs are the same, positive and positive, so we add them, 22, and keep the bigger sign here. So the answer is positive 22, or just 22. Okay. Once again, the parentheses at the beginning are being used here as just highlights. Hey, I have a negative here. Look at me, I'm a negative. Let's look at number 16. What's different? Well, now it looks like we've got a negative out front, and then we're subtracting a positive number. If it helps you, highlight what the different signs are of the number. It might even help you to rewrite it as negative 29 minus a positive 21. The typesetting in this particular program puts all minuses, negatives, they're all at that same level. I prefer to kind of put my signs of my numbers a little bit up high, and so I can really recognize them as attached to that number, and then my operations more in the middle. Again, that's a style. You can do whatever is working for you. If you know, how do you know if you need this or not? Well, as you're looking at the page, if you're asking yourself, or you're wondering, is that a minus? Is it a negative? Am I adding? Am I subtracting? What's happening with all these signs? If you're unsure, if you're not confident, and you're not getting consistently right answers, you need to start applying some of these methods. Okay, so I just started by rewriting the problem and making sure I really understood I had a negative 29 minus a positive 21. Okay, don't worry about same or different signs yet. The first thing is to change that subtraction to an add, and change the second number to be an opposite sign of how it started here. Okay, so we're going to add the opposite, and then we bring those numbers down. Notice the negative 29 stays a negative 29. That opening number stays the same way the whole time. Okay, it's like the opening act, and then we're just changing up the finale here, how we're going to finish, and it's just a way of changing how it looks. Okay, so then this becomes adding the negative 21. Now we take our process. Do we have same or different signs? We have same signs. They're both negative. We add here, because the same signs, we find the sum. 29 and 21 is 50, and then we keep the bigger sign. Okay, now I put bigger in quotes because they're the same, so there's really no sign that's bigger than the other. We're just attached to a bigger number than the other. It just allows us to have that same rule the whole time, because then when the signs are different, we always are automatic, keep the bigger number. Okay, so our resulting answer here is negative 50. If you think number line, if you start at negative 29, you go to the left 21, you'll land at negative 50. You're already negative, you land negative. Okay, so here's one for you to try. Negative 65 minus a negative 65. I actually went, with this try problem, I went a little more challenging here, but the rules don't change, okay? You add the opposite and then use our rules for adding. So hit the pause button, try this one on your own, and we'll reveal the answer. And the answer to number 18, you should get 0. And this is one we will highlight in class and talk through this one. Okay. Plus bring any questions, of course, and we'll hit some of the highlights of the notes as well when we're in class together. Okay, so let's continue on here. What's different about these next two examples? Well, as I mentioned at the top of the page, this is subtraction of real numbers, which means that not only are we learning how to deal with positives and negatives, but we're going to throw in fractions, we're going to throw in decimals. Towards the bottom of the page, if you've peeked ahead, we're going to throw in irrational numbers. That's a part of the reals. So we've got pi going on here. No fear, though. We can deal with this because the steps are not going to change. It's just the types of numbers we're dealing with here. So let's get it set up. There's an expectation coming into Math 60 that you can get a handle on your ability to deal with fractions and decimals. Most people, decimals comes back pretty quickly. Fractions can stay a little bit rusty and you can lose some of your confidence there. So if you haven't arranged for some regular help or resource and you know you are still struggling with fractions, please get some help right away. See me if you aren't sure where to turn, and we'll get you to where you need to be, okay? So let's go ahead and look at this. It is subtracting a negative, so we're going to deal with it the same way we did before. We're going to now add the opposite. Again, we don't worry about the sign of the first number. For now it's positive. We're just dealing with it, with changing the subtraction to an addition and the sign of the second number to its opposite. And again, the parentheses here are just, hey, look at me, I'm a negative number. It's just a way to kind of highlight, because this typesetting is not as good with all these minuses going straight across in the middle. Minus signs. Okay, so when we add the opposite, we're going to get an adding of a positive 1/10. So we bring down our 1/10, bring down our 2/5 here. We've got positive and positive, so those are same signs. So we're going to go ahead and just add and keep, because same helps us remember the word sum. Sum means to add. Add and keep the bigger sign. In this case, the answer is going to be positive. Okay. Now, again, fractions, you should be at this point where you go, okay, adding means I need like denominators, so I'm going to convert the 2/5. The way I convert 2/5 to have the same denominator is to multiply by the factors that are missing. 5 times 2 will get me 10, so I need to multiply the top and bottom by 2. That was going to give me 4/10 plus a positive 1/10. And then you add the tops together. 4 plus 1 is 5/10. We're going to keep that bigger sign here. Once we've converted, you can see easily which one's bigger. 4 is greater than 1. So this is a positive 5/10. This reduces to a positive 1/2. You always want to get in the habit of reducing. Leaving it in, the question really this term is, do I want to leave it in mixed or improper? And you'll see that improper shows up a lot because we're training ourselves for how we're going to use it as slope in chapter 4. Okay, so a positive 1/2 should be where we're at for number 36. Let's look at number 42, decimals. Okay, but the idea of how to deal with positive negatives doesn't change. Again, the parentheses are just saying, hey, look at me, I'm a negative here, you're subtracting a negative. Let's go ahead and start by changing the subtraction to addition, changing the sign of the second number to its opposite. So we're going to be adding a positive here, bringing down the two numbers. We have a negative 4.6, and we now have a positive 1.1. over to the side here, I'm just going to note that we have different signs. One's negative, one's positive, which means that we're going to subtract. And then, of course, we're going to keep the bigger sign. And in this case, 4.6 is bigger, so I'm going to keep that negative in my final answer. Now, it's adding together, so if you need to, just off to the side, because remember, Chapter 1 is a no calculator exam, so don't grab for your calculator. Start training yourself for the exam now. So 4.6, 1.1, you line up those decimals. 6 plus 1 is 7. 4 plus 1 is 5. So we get a 5.7. It's going to be negative. So negative 5.7 on that. Oh, I'm sorry. Oh my goodness. I got to talking about the exam and totally forgot what my instructions said to do. Oh goodness, subtract 4.6 minus 1.1 because the signs were different. 6, you're probably screaming at the screen here. Well, I guess we got to see who's awake and who's not here. 6 minus 1 is 5. 4 minus 1 is 3. That's the better answer. Keep the bigger sign, negative 3.5. Oh, that's the danger of writing in pen. It's colorful, it's pretty. Your mistakes are there for everyone to see for the rest of the time. What if they start to look like this, where what's different is we've involved an irrational number, okay? Remember at the top of the page, subtracting real numbers. That's your counting and naturals, that's your wholes, 0 could be involved. Integers, there's your negatives. Rationals, fractions, decimals, irrationals. Numbers that have decimals that don't repeat, don't end. They cannot be put into fraction form, an exact fraction form. So the good news is, as we head into this realm of learning how to deal with unknowns or algebra, pi can be treated as such. It can be treated just like a variable. And so we've got 4 pi minus a negative 12 pi. It's like we're combining, it's not like, it's as if we were combining like terms. Okay? If pi were an x or a y, we'd be treating it as like terms. We're going to do that same thing now, just leave it in terms of pi. I'll write that phrase down too. Okay, so 4 pi minus a negative 12 pi. We're going to do the same steps we've been doing all along. That's going to be key. While the problems are easy and you can do them in your head at the beginning of the assignment, especially there's a lot of you, it's starting to really click back into place, the math that you knew coming into here. Okay, you've de-rusted, things are clicking, coming back, and you go, oh, I don't need to write all this out. I know these. I can see these and do these. These are easy. Beautiful. I love that. But you want to realize they will get harder, like number 50, okay? They will start looking a little different maybe than what you're used to. If you've been practicing the steps even on the easy ones, you're going to be totally ready when you come to the more difficult ones because the steps are the same. Okay? So just some word of advice, especially if you are finding that as you get through the practice sets, you're struggling towards the end and feeling like you don't know how to do these problems. It may be time to start doing some of the steps and showing the work earlier on in the assignment. But see me for clarification on that too, if you're just wondering how you can get better at this. Okay, so instead of subtraction, we're going to change this to adding, and we're going to change the second sign to be the opposite of what we start with here. So, and I'm going to move this up just a little bit. We're going to be adding the opposite. The opposite of a negative is a positive here. And then we bring down the numbers. So we've got a 12 pi that we're bringing down, and we've got a 4 pi, and this has been positive the whole time. So once we change subtraction to adding the opposite of that second number, involve the second term, now we look to see what we have in terms of adding positive negatives. And we've got same signs, so we're going to add. The same leads us to remember the key word of sum, which means to add, and then we keep the bigger sign, and of course, in this case, it's just the answer is going to be positive. So 4 pi plus 12 pi, 4 and 12 is 16 pi, and that answer is going to be positive. So 16 pi. So Make sure that you're taking the time as you do the notes. I know that you are investing a lot of time here, and I appreciate all the hard work you guys are doing. Coming to class, doing the practice problems, watching the video notes. As you put the time in, though, do take just those couple extra moments at the end of each chunk to kind of make sure you've copied everything. Highlight for yourself the questions. So if there's something you were unsure about, even if it maybe is what feels like it might be off topic, it's never off topic, okay? Highlight for yourself with a little star, question mark. Use an actual highlighter, like a yellow highlighter or something, to so that when you come to class and you go, what was that question I had? You can easily find it. And then also take a moment to talk it through what you've just seen happening. Okay, following along with me is great, and being able to understand what I'm doing here in front of you is great, but that's just the initial step. That's not enough to get you ready. You need to start to own it, and one of the quickest ways to do that is to talk it through and to say it in your own words, and ideally to grab someone else and explain it to them. So if you have a live audience, that's awesome. If it's just you as you're doing these video notes, just talk it through out loud. You'll be amazed at how much and how quickly it can help you be prepared and get it to long-term memory. Okay, we'll see you at page 2.